Welcome to the short course on Lambda Expressions in Java. Lambda expression was first added in JDK 8 and since then it had changed the way the code is written. It is something similar to what generics had done when it was added in Java 5. Come, let's see what all the new features Lambda expression has brought to the Java programming language. As mentioned earlier, it was added in JDK 8 and it significantly enhanced the power of Java majorly in two areas. Number one, it added new syntax elements to it and that increased the expressive power of the language. And number two, it helped in adding new capabilities into the standard Java API libraries. Examples of those capabilities are parallel processing in multi-core environments and the new Stream API which supports pipeline operations on data. Now let's try to understand what lambda expression is. In order to understand lambda expression, there are two key constructs associated with it. One is the lambda expression itself and the other one is the functional interface. Let's define each term one by one. Lambda expression is essentially an anonymous method, but this method does not execute on its own but provides implementation for the abstract method of a functional interface. Hence, lambda expression results in an anonymous class and it is commonly referred to as closures. Let's talk about functional interface now. A functional interface is an interface which defines one and only one abstract method, and normally that abstract method defines the action of the interface. Hence, all the functional interfaces are single action interfaces. Example of this functional interface is standard runnable interface because it defines one and only one abstract method called run, and this run specifies the action of the interface. So to summarize, lambda expression in Java is an anonymous method. It does not execute on its own but provides implementation for the abstract method of a functional interface. Hence, functional interface and lambda expressions are closely coupled together. Now let's talk about new syntax element and the operator added by the lambda expression to the Java programming language. One important operator is called a lambda operator, which is denoted by an arrow symbol, and hence it is also called as an arrow operator. Let me switch to Sublime Text so that we can write a simple lambda expression and then try to see how lambda operator works on it and how lambda expression is constructed. I'm just writing a simple lambda expression here which returns a constant value. Now this is a typical lambda expression. As you can see, the arrow mark over here is a lambda operator which divides the lambda expression into two. The left of the lambda operator takes any parameters it requires for its operation, and right of the lambda operator is called lambda body, which represents the action of the lambda expression. Here the action is just to return this constant double value. Let's write one more example and try to understand that. Here, instead of simply returning a constant value, I'm just trying to do some calculation and then return it. So the first example just returns a constant double value, but in the second we are doing some calculation and then returning a variable double value. So these two are a common example for a simple lambda expression with no parameters and a single line lambda body expression. Now let's try to write a lambda expression with a parameter in it. Let's say the name of the parameter is an lambda operator and the operation would be to check if a given number is even or odd. Now let's write a normal or regular method for the lambda expression written in line 5 and see what are the differences between them. The lines 7 to 9 represent a regular Java method for the lambda expression on the line 5. By comparing these two, there are three differences that we can immediately identify with it. The first thing is that lambda expression or the anonymous method doesn't have a return type like we have in the normal method. And second difference is that the input parameters in the normal method have type associated with it, but that is missing over here. And the third difference is the return statement which is not present in the lambda expression. These differences become obvious when we actually implement the lambda expression with a functional interface. So let's start with it. Let's write some code and try to implement lambda expressions. I use IntelliJ IDE to code, and I already created a demo class with a main method in it for the Java program to start and run. Since the very purpose of lambda expressions is to provide implementation for an abstract method of functional interface, our first step here would be to create a functional interface. Let's do that. Create a Java class, change the type or kind of class to interface, give a name to it. Now, in order for this interface to get qualified as functional interface, it must define only one abstract method. Let's do that. The return type of this method would be double, name of the function, and it takes no input parameters. Our functional interface is ready. Let's switch back to the demo class. Inside the main method of the demo class, let's create a reference for the functional interface. Create a reference for the functional interface. How do we do that? My interface. This is how we get the reference of a functional interface. Once functional interface reference is defined, the next step is to write lambda expression and assign it to the functional interface in the assignment context. Assign lambda expression to the reference using assignment context. My interface equals a simple lambda expression which takes no input parameters and then does a small mathematical calculation here of picking up a random number and multiplying it by 10 to give a random value to us. So this is what this lambda expression is going to do. Once we assign a lambda expression to the functional interface, we are left with only one step, that is to call this lambda expression to get executed. How do we do that? We'll do that with the reference of functional interface. Let's write a sysout statement. Lambda called, invoke lambda expression or anonymous method with the reference to the functional interface. Let's save this class and try to run. As you can see in the output window, a random number is displayed in here. Let's try it again to see if it prints a different number than the previous one. Yes. Okay, this time it's completely a different number. So this is the basic implementation of lambda expression. Now at this stage, you might be wondering what happens behind the scenes, how this mapping occurs, and how lambda expression provides implementation for the functional interface. In order to understand that, we need to be familiar with one more term called target type context. Target type context is nothing but the reference of functional interface here, because lambda expression provides implementation for the method of functional interface. Now, what happens behind the scenes? When a lambda expression occurs in a target type context, which is my interface, functional interface, an instance of a class is automatically created which implements this functional interface, with the lambda expression providing the behavior or implementation for the abstract method of functional interface, and that method is called through target type context. Lambda expression is executed. This is how lambda expression is mapped with abstract method of the functional interface. Now let's modify this functional interface to take an input parameter here. Let's say int n, and we modify the lambda expression to take the input parameter, and instead of doing math.random, we'll just use the input parameter multiplied by 10, and when calling the lambda expression the input parameter needs to be supplied. Now let's run this program and see. As you can see, the input parameter is 3, which gets multiplied by 10, and a double value of 30 is returned here. So this is how input parameter is used in lambda expression. Now let's write a normal or regular Java method and try to understand the difference between the regular method and lambda expression anonymous method. Now this is a regular method in Java, and this line over here is a lambda expression or anonymous method. So what are the differences that we discussed earlier? Lambda expression or the anonymous method doesn't have a return type explicitly defined for the input parameter, but in case of regular method it is defined, and also the return type of the method itself is absent in lambda expression, whereas it is present over here. And finally the third difference is there is no return statement in lambda expression single line lambda body, but in case of single line normal method a return statement is present. So the question now here is, how does lambda expression or the anonymous method know what type of data it expects and what type of data to return? Since lambda expression provides implementation for abstract method or functional interface, it's easy for the lambda expression to go to the interface and infer data types from there. As you can see, in this interface we have defined abstract method which returns a double value and takes an integer input parameter. So lambda expression goes there to the interface and infers that the input parameter, that is n over here, takes integer type and the return value should be a value of double. So this is how it infers the data types from there. The third difference is that there is no return keyword over here. Since it is a single line lambda body lambda expression, return is not a mandatory over here. Now what happens if I explicitly define a data type here for the input parameter, say int. Let's comment out this code or delete this code. Let's run. As you can see, explicitly defining a data type for the input parameters did not cause any changes in the result of the code execution because it matches with what is present in the my interface. The purpose of lambda expression is to provide implementation for this method, and as long as the basic structure or the data types defined here matches with the lambda expression, then there won't be any issues. Suppose if instead of int if I give a double over here, then you would immediately get a compilation error. So as long as the basic structure or the data type matches with what is present in the functional interface, then lambda expression would execute fine. Now let's modify this interface to take multiple input parameters, say for example int d, and in lambda expression n comma t, and instead of multiplying the input variable n with 10, we'll multiply n and d here, and when calling the method we need to supply one more input parameter. Let's run this to see how it works. The output is 15. So this is how it takes multiple parameters in case of multiple parameters being used in the functional interface. Now one more thing to remember here is that In the previous example, we explicitly defined data type for the input parameters in the lambda expression also. Let's do the same here and see what is the output of the program. The output of the program does not change from the previous one. Now we know that lambda expression refers functional interface to infer types for the input parameters. In this case, there are two input parameters with int, and there are two input parameters here int explicitly defined. So if you want to define the type of input parameters explicitly always in lambda expression, then it must be consistent. What I mean by consistent here is that you cannot have just int defined for one parameter and absent for another one. So it refers the functional interface and infers the type, but if you explicitly give for one and omit for another one, then it would be a compilation error. So if you give, or if you want to provide or explicitly define data types for input parameters of lambda expression, then it should be given to all or omit for all. So this is one important point to note here when writing lambda expressions. Let's switch back to the interface and change this method's parameter to 1 instead of 2 parameters. Come back here and change in the lambda expression as well. Now this arrow operator brings in a nice piece of syntactic sugar. Now if there is only one input parameter, then you can omit this parenthesis. Run this program to see the output. The output is same as the previous run. So this is a nice piece of syntactic sugar that Java provides with the introduction of lambda expression and lambda operator, also called as an arrow operator. It is up to the developer to have parenthesis for a single parameter, but if you want to maintain consistency, the recommendation is to use the parenthesis always. But it's a nice piece of syntactic sugar to learn. Okay, let's delete all this. Go back to my interface and change the return type to int. Come back here and repeat the same steps of creating a reference. With this one, we'll try to see an example for multi-line lambda expression. So my interface equals takes one input parameter, and this time we are going to write a multi-line multi-body lambda expression, so it should be surrounded with curly braces. In case of single line lambda body, it is not required, but as with regular Java programming constructs, any block of code should be enclosed between curly braces, so that same concept applies over here as well. So in this example, we'll try to calculate a factorial of a given number. So further, let's first say result equals 1, and then use a for loop for int I equals 1, I less than or equal to the given number, and then incrementing I, result multiplied with I. Finally, so when compared to single line lambda expression, there are two differences that we can see. One is that curly braces are introduced for the block of code to be written, and there is an explicit return statement. Now let's call this lambda expression multi-line lambda expression and see what is the result. Then pass the value of 5. Let's run and see what would be the output of this program. Okay, factorial of number 5 is 120. So this is how a multi-line lambda expression is written. A multi-line lambda expression is usually called as block lambdas, whereas a single line lambda expression is called expression lambdas. So this is all I wanted to cover in this course. Hope it was helpful to understand the basics of lambda expression and how it is implemented. Thank you.